Today's first day, we'll be dealing with confidence intervals, one sample means. So let's take a look and see what we got here. So I'm going to not, the activity we did in class is something about memorizing states. So I'm just going to kind of follow with some of the other discussions. So what we're dealing with in this unit is we're dealing with confidence intervals for means, for one sample mean. So what it's going to be is this x bar plus or minus t star times sx over the square root of n. So let's go through what each piece means. So this first piece, x star, that's going to be my point estimate. It's my best guess. It's the mean I get from the sample. So basically, that's my point estimate right there. Okay, this guy right here is going to be my margin of error. So again, this is the variability that I'm building into my estimate. So that's my margin of error. So point estimate plus margin of error. Now, the t star is our critical value, kind of like our z star was in the last unit. And this sx over the square root of n is our standard error, the standard deviation of the statistic, in other words. So basically, this is saying that if I took a sampling distribution of size n, this would be, I'm using my standard, my sample standard deviation as my best guess. So this is, here's my guess of the mean plus or minus a certain number of standard deviations. Okay, so that's what we're dealing with. Now, the first question I'm going to talk about is how you figure out a sample size. It's oftentimes a multiple choice question. So city council members want to estimate how many pounds of trash households in their community produce per week. To determine the estimate for the standard deviation of weight trash produced by a small random sample of households was selected and their trash was weighed on garbage day. This produced a standard deviation of 36 pounds. So what they're saying is they actually went out and they came up with a standard deviation of 36 pounds. And what they're trying to do is they're trying to get the margin of error no more than 3 pounds. So what we're dealing with here is we're going to take this entire thing here, this margin of error. Now here's the deal. Because we're trying to figure out a sample size, when you figure out a sample size, we're actually going to use z star. This is the only time we're going to use z star in means. Z star times that standard deviation we came up with over the square root of n has to be less than or equal to 3. And what we're going to do for table B, we're going to use, in this case, the infinity row for 95%, so 1.96. This is the only time this happens with means, is when we're figuring out sample sizes. So it's going to be 1.96 times the standard deviation we just came up with, 36, over the square root of n. It's got to be less than or equal to 3. And now, welcome to algebra 2. Because what we're going to do is we're going to divide both sides by 1.96. So the first thing we're going to do is we're going to do 3 divided by 1.96. And that's going to give us 1.531. So that's going to say 36 over the square root of n is less than or equal to 1.531. Let's multiply both sides by the square root of n. Multiply both sides by the square root of n. So now what I'm going to have is I'm just going to rewrite it to put the n on the other side. 1.531 square root of n is greater than or equal to 36. Now what I'm going to do, I'm going to divide 36 by 1.531. And that's going to give me the square root of n is greater than or equal to 23.514. And then what I'm going to do is I'm going to take that 23.514, I'm going to square it. Squared, and that's going to say n needs to be greater than or equal to 552.9. We always round up. So the sample size we need is 553. So we would need to take 553 households to get within a margin of error of about 3 pounds. So that's, again, that's a very rare one. I just want to show it to you so you can see it. You can watch it, look at this a couple times, but oftentimes comes up as multiple choice question. Okay. Now let's talk about the real thing. The real thing is how I'm going to do a confidence interval for means. So I am still going to go ahead and use the panic. I'm still going to use panic to do it. P is going to be my parameter. So in this case, mu is the true mean weight of trash for all households in this community, I stole it right from the stem of the question. I'll show you where I got it from. Mean weight of all trash households in this community. So there's my P. A. Okay, first thing I want to do is I need to check random. When I look at this, I go through, I look at it, I see random sample. So that tells me state's random. Okay, next one we're going to look at is we're going to look at independent. Or look at independent. And independent is the 10n check. So we're going to do 10 times n, or in this case, 10 times 15. And that's 150. We're going to compare that to the population of households in this community. What I'm going to say is I'm going to assume more than 150 households in this community. Okay. Now, here's where a new check comes in, large enough. Now, here's where I got to actually pay attention to some stuff. The first thing I'm going to look and see, does it say anything in here about trash produced being normally distributed? And I look at this problem and I don't see that at all. Next thing I look at is to see if my sample size is sufficiently large. Is it 30 or larger? Because then I can use the central limit theorem. Unfortunately, that's not the case. So what I'm going to do now is I am going to put the data into the calculator. So what I'm going to do is all of this data that's there, I'm going to put in the calculator. So we do stat, edit, and I'm going to put in those numbers: 1114.8, 74.3, 80.1, 41.5, 99.1, 31, 93.1, 118.9, 26.5, 33.1, 88.3, 46.1, 119.7, 46.4, and 19.8. Okay, so I've got my 15 data points in the calculator. What I need to do is I need to look at that data. I need to see that data visually, and I need to see that there's no strong skew or no outliers. So the way I'm going to do that is second y equals, I'm going to turn on the stat plot. And what I'm going to do is I'm going to use a histogram. Histogram is a pretty safe bet. It'll give us a good visualization of the data. And I'm going to zoom 9 it. And when I look at that data, do I see any strong skew? In this case, the problem is there could be some potential strong skew. I could see some issues there. But in this case, what I am going to do is I'm going to, let me just check one thing real quick. Right here. I can look at this one way. Let's look at, there's another way to look at it. We'll go ahead and we'll do second y equals, and we'll look at the box plot. That's another way to look at it. So I'll do box plot with outliers, and I'll do zoom 9. And again, if I look at this, first of all, I can tell you there's definitely no outliers. And then looking at this box plot, one or the other in this case, I don't see a whole lot of strong skew to that one. Now, again, let's go back and look at that histogram again. I will tell you, zoom 9. That's not really strong skew because of these bumps here. I mean, I know it's a weird looking one. It's not normal looking, but there's definitely not strong skew to that. So each one, whether you use the box plot or the histogram, either one is fine. I'm going to go ahead and I'm going to use the histogram. I'm sorry, the box plot. And what I want to do is I want to trace down this histogram. So what I want to do is I want to give a rough estimate of this. I'm going to draw myself a line down here. I'm going to put my histogram down. And what I'm going to do is I can use the trace button to give myself some order of what the numbers are down below. So if I hit trace and I arrow over, I know that this first one is at 19.8. So what I can do is call that about 20. That's about 33. So we'll say that's going to be, say, about 30 here. We'll do 40, 50, 60, 70, 80, 90, 100, 110. And what I'm going to say is I see no strong skew. I see no outliers. And this is going to be the new thing. It's going to be a little bit more work on the large enough check. We're going to have to draw the picture. So now for the end stage, I am going to construct a one sample T, that's one sample T interval at 95% confidence. And here's how I figure out that T star value. And the way I figure out the T star value is I'm going to look at degrees of freedom equals n minus 1. So in this case, degrees of freedom equals 15 minus 1, degrees of freedom equals 14. I'm going to go to the 14 row. I'm going to go to the 95% column. And as I come across, I find out that that number is 2.145. That's my T star value is 2.145. So my T star is 2.145. And now what I need to do is I need to go ahead and I'm going to fill in this value right here, x bar plus or minus T star Sx over the square root of n. And now what I need to do is I need to figure out my data points. And the way I'm going to figure out my data points is I just put the data in the calculator. I'm doing stat, calc, 1var stats. I want to run it on L1 and it's going to tell me my data. So what it's going to tell me is that my X bar is equal to 68.847. It's going to tell me that my SX is equal to 35.777. So now what I can do is I can go ahead and I can plug in the numbers. I can say 68.847 plus or minus that T star value of 2.145 times standard deviation 35.777 divided by the square root of 15. And now I'm going to pick up my calculator to get the interval. The way I do it is stat tests. And what is going to happen on this one is when I want to run an interval, I'm going to use number 8. Number 8 is a T interval. And I can either run it with the data or with the stats. Now, here's the deal. Since I've already put the information in my calculator in the L1 list, I can use data. If I didn't, I'd have to go to stats, and then I'd have to type in those numbers. So notice since I ran it in the calculator, it's there. So either one is fine. I'm going to run it on the data. So L1 is our list. We're going to leave frequency as 1. Our confidence level is 95. We calculate. And it tells me 49.034, comma, 88.659. So our final step, that's C. We are 95% confident. The interval from 49.034 pounds to 88.659 pounds captures. And I'm going to go right back to that stem, the true mean weight of trash for all households in this community, So what I want to show you is, honestly, when we go to do our confidence interval, if you felt comfortable with what we did before, it's the same process in Panic. We changed the symbol here. We obviously changed the word to mean here. The large enough check is a change. Obviously, we're going to say T interval here. We're going to figure out a T star, so our formula changes. But at the end of the day, everything else in terms of my Panic pretty much looks the same. And this is how you do a confidence interval for a one sample mean. So hopefully that helped. Again, please ask questions if you got them. And on the next class, we'll be looking at the difference between two means in a confidence interval on that.